Okay guys, we are now going to look at the effects of mass, length and gravity. We shall also look at friction. What does friction do to the movement of a pendulum? So here is our length. We have length from 0.1 to 1. Then we have mass from 0.1 to 1.5. Then we have gravity. We can change gravity here from 0. When the gravity is 0, there won't be any movement. So from 0 to 25. Also, we can choose here gravity on the moon, on Earth, on Jupiter, planet X. Then we can choose our own, right? So let's choose Earth, our planet. The gravity is 9.81 meters per second squared, right? So if you can notice here, we can choose one pendulum, but okay, we want to use two of them. So we are going to test the length first. So if we test length, everything else has to be the same. Let me try to move this. You see, there are two pendulums here. So let them swing. As you can see, they are swinging. I can start another one here and let them swing. See, they are swinging, right? So the masses are the same. They have to be the same. So let me stop it. So look here, mass for the red one. The red one is this one, right? Is 0.10 kg. Then the blue one is 0.20. No. We have to make it equal. So the minimum mass we can have is 0.1. They are at 0.1, both of them. The mass is the same, gravity is the same. The only thing that has to be different really is the, let me take an angle of 20. Let's change the mass of, not the mass, I mean the length of this red one. Red is this one, so the blue is 1. Let's make this one 50, around 50, or even, yes, 50 is okay. Then what do? They're going to start at the same time from the same point. So we could time the period, we could count the number of oscillation and have the stopwatch here and then calculate, but we don't want to do that really. Even the period, I don't think it's necessary to do that, because we are going to visualize. So how will we know if the length has an effect? We want to see the time taken, right? The time taken for these two. Will they arrive back at this point here at the same time or not? Oh, what should I do? Maybe I should make it move a little bit slowly so that we see what is going on and talk about it. So I'm going to start the, or maybe let me just stop watch here. Let me have them oscillate. Yes, look at red. Red is already in front. It's coming back. Red is coming back because the string is short. Oh, it has arrived. I stopped the swinging because red has arrived, because it has a shorter string, right? The length of a pendulum has an effect. It has an effect. Okay, let's start once again. Now we are going to time, right? We'll stop when the red one arrives, or when the first one arrives, we'll stop. Stop when the first one arrives. Yes, the red one is already in front. 2, 4. It's coming back. coming back, it's coming back. Stop. You see, the red one took 1 second 1.42 seconds. It has arrived and it is going back, but this one hasn't arrived. So length has an effect. We know that this one is 1.42 seconds, right? Let's see the time this one takes. So we are going to stop our stopwatch when the blue one arrives to its starting point, right? Oh, I forgot to start the stopwatch. I'm sorry. We have to be careful, guys. Yes, let me press it. Start. We are waiting for blue. We don't mind red. Red will always finish first because it has a shorter length. Shorter period. Blue arrived. See, it took 2.04 seconds. The shorter one took 1.42 seconds. So that's it. Now what can we say? Length has an effect. So if the length is shorter, the period is shorter, right? It takes less time. So that's it about the length. Now let's look at the mass. What can we do? We are going to increase the mass of the blue one. The blue one mass is here, maximum 1.5. Remember, the length have to be the same. So the red one now, we will have its length 1 meter, just like this one, right? Let me start it. As you can see, they are swinging. So they have to start at the same time. Remember, at 20 angle of 20 at the same time. Now let's let them swing. Start. Oh. They are swinging at the same time. No bulb is in front, no bulb is behind. So what can we say? About the mass? It seems mass has no effect. Mass has no effect on the period of a pendulum. Whether the mass is small or bigger or whatever, the period of a pendulum will be the same. It does not depend on the mass, right? So that's it about mass, no effect. Now we stop it. We'll choose just one pendulum, and let me make it a bit like this. I don't know if these are visible, but I really hope they are. Okay, now we want to look at gravity. We are going to look at gravity. So we are going to time the period, rather, not the period, time taken to complete one oscillation, not the time for oscillations, right? So the gravity, let me choose a smaller angle, 10, and then I will choose, here is our gravity, right? This is on Earth, remember? No, Earth. Let's choose the moon. The moon gravity is 1.62 meters per second squared. That's okay. We chose the moon. The friction, zero friction, non-friction. Okay, so we are going to start our pendulum to swing. It is, no, I made it to swing slowly. Now we want it to swing fast because you're just going to time from here. It's normal, right? It's normal as it will swing on the moon. Started. As you can see, he's swinging, he's swinging, he's swinging. I want you to memorize this movement because I'm going to change the gravity, and I want you to see which one is quicker, okay? The oscillations. So the period, let's just count it automatically. Period counter. Here is the part, you see, to and fro. So on the moon, normally the period is 4.9, almost 5 seconds, 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 almost 5 seconds. Let's stop it. Now let's change the gravity and see what happens on Earth. Now we are on Earth. We are on Earth. Let's start it. What do you notice? What do you notice? What do you notice? It's a little bit fast, right? And also the period here is 2.0098 seconds, almost 2 seconds. But I would like to go back. I'd like to go back and make it a little more. Yes, you see, I chose the gravity of 0.50 and let me choose 20. I want you to be able to see the difference really, okay? I'm not going to press anything here. I just want you to visualize it. I want you to visualize it. As you can see, under a gravity of 0.5 meters per second squared. That is the gravitational acceleration, right? You saw it. I'm stopping it. I'm increasing 25. So it's not on Earth. At some planet. Let's start our pendulum swinging. See. You see that? Now it moves faster. It swings faster. So it will take less time. The period will be shorter because the gravity is higher. The gravity is higher, therefore it will complete an oscillation in a short period of time. So that's it about length, mass, gravity, and friction. Now let's increase the friction a little bit, guys. I want you to see something. What friction does. Look what happens now. It will eventually stop because I've increased friction. It just stopped. So the reason why a swinging pendulum stops, it is because of friction. Could be friction due to air or friction on the string itself, right? Yeah, as it touches at the fixed point, there is friction. So eventually it will stop. A swinging pendulum eventually stops. So this is the reason. Well, with time, remember, with time, a few oscillations. The reason is that we want to minimize human reaction time error. We are minimizing it. We are reducing it. We cannot avoid it. We are minimizing it. So we are spreading the error. Okay? So that's it about this mass, length, and gravity, and friction as well. So in summary, we are saying the period of a pendulum depends on the length. The shorter the length, the shorter the period, and vice versa. Meaning, if the length is longer, the period will be longer. Then gravity, the higher the gravity, the shorter the period. And then we are saying, note, mass has no effect. Mass has no effect at all. And another thing, timing many oscillations to determine the period reduces or minimizes the reaction time error, right? So that's it about the simple pendulum.